Hello students, welcome to this lesson. This is the last lesson of chapter 5, continuity and differentiability. In lesson 1 on Rolle's theorem and mean value theorem, we studied Rolle's theorem, statement of the Rolle's theorem, then verification of the Rolle's theorem for a given function. Let us continue. In this lesson, lesson 2, let us study mean value theorem. The statement of the mean value theorem is this: let f from closed interval a to b to r be continuous on the closed interval ab and differentiable on open interval ab, then there exists c such that in ab such that f dash c will be equal to f of b minus f of a divided by b minus a. This is the statement of the mean value theorem. Let us compare this theorem with the previous theorem. In Rolle's theorem, what was the condition? First, it is continuous. Second, it is differentiable. Then the one more condition is f of a must be equal to f of b. These are the three conditions for Rolle's theorem. But here the condition number 3 is not there. F of a is not equal to f of b. But if the first two conditions are satisfied, then the theorem says f dash c will be equal to f of b minus f of a divided by b minus a. So here if you put f of a equal to f of b, once again f dash c becomes 0. So that becomes Rolle's theorem. Therefore we can say mean value theorem is the general theorem and Rolle's theorem is a particular case of mean value theorem, because if you use the condition f of a equal to f of b, then it becomes Rolle's theorem. So this is one important difference. Now let us try to understand the geometrical meaning of this theorem, mean value theorem. So consider a function y equal to f of x, say a f of a and point b f of b. These are the 2 points on the curve, say where a is the starting point, that is closed interval, and b is the end point of the closed interval, where the function is defined, where it is continuous and where it is differentiable. So this is the thing. Now if you join ab, then definitely f of b minus f of a divided by b minus a, that is the slope of the line segment ab. Now what the theorem says is that is also equal to f dash c. Now what do we mean by f dash c? F dash c geometrically means it is the slope of the tangent passing through c, that is f dash c. Now in the diagram what it shows is these two lines, that is tangent is parallel to the line segment AP. That is what the theorem geometrically can be interpreted. So this is the meaning. Now let us take some example. Example 4 in the worked out section. So verify mean value theorem for the function f of x equal to x square in the interval 2 to 4. So here we have f of x equal to x square. This is the function, and given closed interval is 2 to 4, and the function f of x is definitely continuous in the closed interval because it is a polynomial function, and we know that every polynomial function is continuous. That means the first condition is satisfied. Second, the function f of x is also differentiable in the open interval 2 to 4. Therefore the second condition of the mean value theorem is satisfied. Therefore now we have to find f dash x. F dash x is 2x. Now the theorem says f dash c must be equal to f of b minus f of a to b minus c. Let us find that. Now f dash c equal to f of b minus f of a divided by b minus a. So this is the condition, third condition. So now f of 4 minus f of 2 divided by 4 minus 2, that is a equal to 2 and b equal to 4. So simplify. F of 4, that is 4 square 16, minus f of 2, 2 square, that is 4, divided by 4 minus 2. Now simplify this, you get 6, because 16 minus 4 12, 4 minus 2 is 2, so for 12 by 2 6. So this is f dash c. Also f dash c is equal to f of b minus f of a b minus a implies now 2c equal to 6, because f dash c is 2c. Therefore now c will be equal to 3. Now what you have to check is whether this 3 belongs to the interval. So you can see now 3 belongs to the open interval 2 to 4. Therefore, mean value theorem is verified. So let me sum up. It is continuous, it is differentiable, and we have determined the C applying the condition f dash C equal to f of b minus f of a divided by b minus a, and that C, that is the value 3, that belongs to the open interval 2, 4. Next, let us do the examples 5.8. First one, examine whether the MVT means mean value theorem is applicable for the following functions. First one, f of x equal to greatest integer function x for x belonging to the closed interval 5 to 9. Second one, f of x equal to greatest integer function only x belonging to the interval minus 2 to 2, and f of x equal to x square minus 1 for x belonging to 1 to 2 closed interval. So 3 examples are given, we have to verify. First one, let us take f of x equal to greatest integer function x, and the given interval is 5 to 9. Now, we know that f of x equal to greatest integer function x is not continuous at all integral values. This we have proved in continuity. Therefore, in particular, the function is not continuous at x equal to 5, x equal to 6, x equal to 7, 8 and 9, because the given interval is 5 to 9. Therefore, the first condition itself is not satisfied because the function is not continuous. Therefore, we cannot apply mean value theorem here. So, this is the answer. Same reason for the second also, because only change is interval. So, f of x is greatest integer function once again, and the given interval is minus 2 to 2. Once again, this is not continuous at all integral values. What are the integral values for this one? Minus 2, minus 1, you can see here, then 0, 1 and 2. Therefore, mean value theorem is not applicable for the second function also. These are the reasons. Then for the next one, f of x equal to x square minus 1, interval is 1 to 2. Now here it is continuous, definitely, because it is a polynomial function, and f of x is also differentiable in the open interval 1 to 2. So these first two conditions are satisfied. Therefore, we have to proceed. F dash x equal to 2x, differentiation of x square minus 1. Now, f dash c equal to f of b minus f of a divided by b minus a. This is the formula we have to apply. So, f of 2 minus f of 1 divided by 2 minus 1. Simplify. F of 2 is 3 because 2 square is 4, 4 minus 1 is 3, and f of 1 is 0. So 1 square minus 1 divided by 2 minus 1 is 1. So the answer is 3. Next, f dash c equal to f of b minus f of a divided by b minus a implies 2c equal to 3 because f dash c is 2c. So this implies c will be equal to 3 by 2. Now we have to check where is this c. Is it in the required interval? So 3 by 2 belongs to 1 to 2 because open interval is 1 to 2. So therefore mean value theorem is verified for this one. So for the third example, mean value theorem is applicable. Next example, verify mean value theorem for the function f of x equal to x square minus 4x minus 3 in the interval a to b, where a is 1 and b is 4. So the lower limit is 1 and upper limit is 4. Solution, f of x equal to x square minus 4x minus 3 and a equal to 1, b equal to 4. The function f of x is continuous in the closed interval 1 to 4 because it is a polynomial function. Next, it is also differentiable, function is differentiable in the closed interval 1 to 4. So the first two conditions are satisfied. Then f dash x we have to calculate, which is 2x minus 4. Differentiation of x square minus 4x is 2x minus 4. Now, therefore, now what you have to do is f dash c equal to 2c minus 4 and f of b minus f of a divided by b minus a we have to calculate. So calculate it, f of 4 minus f of 1 divided by 4 minus 1. So what is f of 4? It is minus 3, you can check. 4 square is 16, 4 into 4 is minus 16, therefore 16 cancels, minus 3 remains. then minus, second one is minus 6, that is f of 1. You can substitute x equal to 1 in the function. 1 square minus 4 into 1 minus 3, that is 1 minus 4 minus 3, that is 1 minus 7, so it is minus 6, divided by 4 minus 1 is 3. Therefore it is 3 by 3, that is 1. So yeah, now what you have to do is f dash c equal to f of b minus f of a by b minus c implies 2c minus 4 must be equal to 1. So this implies 2c equal to 4 plus 1, that is 5, or c equal to 5 by 2. Now we have to check 5 by 2 whether it is in the given interval. So you can see it belongs to 1 to 4. Therefore all the conditions of the mean value theorem are verified. So this satisfies mean value theorem. Next, example 5. Verify mean value theorem for the function f of x equal to x cube minus 5x square minus 3x in the interval ab, where a equal to 1, b equal to 3. And there is one more question. Find all c belonging to 1 to 3 satisfying the condition f dash c equal to 0. So the function given here is cubic function. Now, of course, first two conditions you have to verify. F of x equal to x cube minus 5x square minus 3x, a equal to 1, b equal to 3. The function is definitely continuous. Why it is continuous? Because it is a polynomial function. Polynomial functions are continuous functions. So the first one is satisfied. Second one is it is also differentiable in the open interval 1 to 3. So the first two conditions are satisfied. Definitely we have to proceed. Now find f dash x, which is equal to 3x square minus 10x minus 3. Differentiation of the given function x cube minus 5x square minus 3x. Now, therefore, f dash c will be equal to 3c square minus 10c minus 3. Then we have to calculate this one, f of b minus f of a divided by b minus a, we have to calculate. So we have to substitute f of 3 minus f of 1 divided by 3 minus 1. So a is 3, a is 1, b is 3. Now what is f of 3? This is minus 27. You can check 3 square, that is 3 cube minus 5 into 3 square minus 3 into 3. So this is minus 27 minus f of 1 is minus 7. You can check, divided by 3 minus 1. Now simplify, you get minus 10, because minus 27 minus of minus 7 is plus 7. So it is minus 20. Below it is 3 minus 1 is 2. Therefore it is minus 10. Now what should we do? F dash c equal to f of b minus f of a divided by b minus c implies, b minus a implies 3c square minus 10c minus 3, that is f dash c, that must be equal to minus 10. So you have to solve this equation. So 3c square minus 10c plus 7, because minus 10 you can take left side, so it becomes a quadratic equation. So solve this one. How to solve? When you factorize, it is 3c minus 7 into c minus 1 equal to 0. Therefore this implies either c should be 7 by 3 or 1. Now mean value theorem says at least there must be one c, but now we have to check whether both are possible or only one is possible. So now 7 by 3 belongs to 1 to 3. 1 does not belong, because 1 is the end point and it is open interval. In open interval 1 is not included. But 7 by 3, which is approximately 2 point something, which is in the interval 1 to 3. Hence mean value theorem is verified. So this is the first part. What is the second part now? We have to find all the values of c which satisfies f dash c equal to 0. Let us proceed. Next, f dash c equal to 0 implies 3c square minus 10c minus 3 equal to 0. So this you have to solve. So 3c square minus 9c minus c minus 3 equal to 0. Factorization, splitting the middle term. So 3c into c plus 3 minus c plus 3 equal to 0. Or you can write c plus 3 into 3c minus 1 equal to 0. Therefore, what are the values of c? C can be minus 3 or C can be 1 by 3. Now we have to all the values. So now C equal to 1 by 3 belongs to the interval 1 3. That means there is only one such value. Minus 3 we cannot include. So that's all. So this is the last question. Though it is a very small unit, Rolle's theorem and mean value theorem, only limited examples are given. So these are the questions. Thank you for watching this video. As I told you, this is the last lesson on chapter 5, that is continuity and differentiability. I have started with the continuity, then we have done lot of questions, then we shifted to differentiation. There also right from chain rule, different techniques of differentiation we have completed, and the last part of this chapter was Rolle's theorem and mean value theorem, very small unit. So this is actually I would have done 2 lessons together, but purposely I divided this into Rolle's theorem separately and mean value theorem separately. Please revise. Please subscribe and share if you like this lesson, and let me continue with the next chapter, that is I have already started application of derivatives. Their rate measure I think I have already uploaded. Then we have to study increasing and decreasing function, approximation, then tangents and normal, maxima, minima. But if you revise this chapter, application of derivatives will be very easy, and it is very interesting also. Let us meet in the next lesson with the application of derivatives. Please watch all the lessons and subscribe if you are not yet subscribed, and share with your friends. This is my request, because when the students subscribe and share and like the lesson, it is a motivating factor for the teacher, as this is my repeated statement in all lessons. Hope you will definitely do it. Let us meet in the next lesson. Till then, bye, take care.